start with the lecture now. So let's share. All right. So let's get started. So today we're going to work on 7.1, which is finding the confidence interval for a population proportion. So whenever we're doing a population proportion confidence interval, what we're trying to do, we're trying to figure out what P is equal to. But the thing is, we don't know what P is. So what we're going to use, we're going to use P hat to estimate what P should be. So in case you forgot what P hat and P is represent, P hat represent sample proportion. P represent population proportion. So we're trying to figure out what the sample proportion is, because you could always find a sample. And using that sample, we're going to try and come up with what the population proportion is. So you have to kind of go over how to find p hat. Let's do the formula. So if you look over here, let me blow it up for you. Here is the formula for p hat. So if we ever want to find what p hat is equal to, p hat is just equal to x divided by n, where x is your characteristic that you're looking for. N is how many people were sampled or how many objects were sampled. So kind of like an easy example. So say if I wanted to figure out like how many female are in a class, X will represent how many total female we have, N will represent how many people we have in the class. So that's how we'll find P hat. Any questions so far for P hat?
No.
Thank you, Samantha. All right, so let's do our first example.
It was Alondra.
Alondra?
It's
Oops, sorry.
okay.
Thank you, Alondra. All right, so for this one, said in July of 2018, a university poll asked 1,783 registered voters nationwide whether they favor or oppose the death penalty for person convicted of murder. 1,123 were in favor. So for this one, what we want to do, we want to obtain a point estimate for the proportion of registered voters nationwide who are in favor of the death penalty for a person convicted of murder. So they say point estimate. So point estimate is the same thing as P hat. So if we want to find a point estimate, where you're going to find what P hat is equal to. So let's go ahead and let's find what P hat is equal to. So for this one, we're going to find P hat is equal to number of people. Oops, people in favor of the death penalty. And pretty much the bottom is the number of registered voter. So on top, we just want how many people are in favor of the death penalty, and the bottom, we just want the number of registered voter, because that's what we want to find. Okay. So let's go ahead and find how many people are in favor of the death penalty. So how many people said to be in favor of the death penalty? So if you want, you can just type it into the chat or just yell it out. Cool, thanks Elizabeth. So 1,123. There you go, 1,123. And what's our sample size? Now, if you look at a sample size, That's how many people they asked. So it's 1,783. Cool. Thanks, Edgar. All right, so all we have to do is divide this up. So let's go over to ClassCalc to divide it up. So we could say 1,123 divided by 1,783. And that's our answer. So we get 0.6298. And that's our final answer for the point of estimate. Any question in regard to our point of estimate? All right, perfect. All right, so let me transition back to my notes. All right. So the notes are a little bit backwards. Let me first go down here. All right, so this is how we're gonna find our confidence interval. So when we find the confidence interval, we wanna find an interval. So the first thing what you wanna do, we're gonna use is find E, where if you look right here, E is the margin of error. So we first wanna find margin of error. So this Z value over here, this is gonna come from the T table I told you last time. And then you multiply that times this. If you kind of remember, this is standard deviation of P hat. Okay, if you remember for the formula for standard deviation of P hat, it was square root of P times 1 minus P divided by N. The only thing different, if you look at the formula we used to use, it was square root of P times 1 minus P divided by N, because that's we knew what the population proportion is. But when we're doing a confidence interval, we don't know what the population proportion is. So if I don't know what the population proportion is, I have to use the estimate. So we're using the point of estimate to estimate what the population proportion is. So right here, you put P hat times 1 minus P hat divided by N. So you multiply the standard deviation of P hat by the Z value, and that will give you the margin of error. Any question on how to find margin of error? All right. So if we go to the formula, if you look at it, it says point of estimate is equal to P hat, which is just equal to X divided by N. So once you find the margin of error and once you find the point of estimate, in order to find the confidence interval, you're going to do point of estimate plus or minus margin of error. So the plus or minus just mean you're gonna do the operation twice. So that means you're gonna do point of estimate minus the margin of error. Then you're gonna do point of estimate plus the margin of error. So you're gonna have to do this twice, one for a subtraction, one for a positive. Any question in regard to the confidence interval? All right, sweet. So let's see. Yeah. All right, so, all right, give me a minute. I think the thing froze. So let me unconnect and connect it again. All right, so we're gonna go ahead and do this problem right now. So for this one said, in July of 2008, a Quinnipiac University poll asked 1,783 people or registered voter nationwide whether they favor or oppose the death penalty for a person convicted of murder. 1,123 were in favor, attaining 90% confidence interval for the proportion of registered voter nationwide who are in favor of the death penalty for a person convicted of murder. All right. So if you kind of remember this one, we already did some of it. So we found p hat is equal to 1,123 divided by 1,783. And when we did that, we got 0.6298. All right, so that's information we already knew. So for part A, it said check the condition to see if we could say that the data is approximately normally distributed. So to say the data set is approximately normally distributed, we have to check the central limit theorem. So if you remember the central limit theorem, we actually have two central limit theorem. One, if we're doing this for the population mean. One, if we're doing this for the population proportion. If we're doing this for the population mean, we just have to check to see if n is greater than or equal to 30. If we're doing this for the population proportion, we have to do n times p hat times 1 minus p hat and check to see if that's greater than or equal to 10. So for this one, which of the two conditions should I use? Should I use A or should I use B? If you want, you can just put it on the chat too. Cool. All right, so we got 2 for B. All right. So B is indeed the one you want to use because if you look at this one, we're doing this for the population proportion. Okay, we're trying to estimate what could be the population proportion of people who are in favor of the death penalty for somebody who's convicted of murder. So we want to use B. Question? All right, no question. So let's go ahead and do B. So we're going to say N, which is 1,783, multiplied by P, which is 0.6298, multiplied by 1 minus 0.6298. So I'm going to do that in my calculator to kind of save a little time. So I'll do 1,783 multiplied by 0.6298 multiplied by 1.6298. So if you work this, you get 415.7. So if you look at 415.7, that's bigger than 10. So since 415.7 is bigger than 10, we're going to say it's approximately normal. And that's it for B. Any question for A? All right, so let's do B. So if you look at B, it says find the critical value. So when we want to find the critical value, you want to find this. You want to find Z alpha divided by 2. Okay, so I'm going to show you how to find Z alpha divided by 2. And for this one, we are going to use the t-table. So if you did print out the t-table, make sure that you have the t-table available with you so you can use it. So first thing we're going to go ahead and do is find alpha. So the way that you find alpha, alpha is equal to 1 minus confidence level. In this case, what's my confidence level? Okay, 90. So you put 0.90. So we say 1 minus 0.90. So you get 0.10. All right, so right here, you're going to put 0.10. So we're going to say z of 0.10 divided by 2. Everybody good how we got 0.10 divided by 2? All right, so what's 0.10 divided by 2? Yeah, 0.05. So you get z of 0.05. All right. Any questions so far? I got 0.05. All right, so this is the moment that you're gonna need the t table. So I'm gonna go ahead and switch this over to the t table. Forgot to download it. Oh well. Oops, no. Okay, so here's the t table. So there's only two things we care about. You only care about this row right here, and we care about this z row. So if we are doing this one, what you want to do in that first row where it says one tail, you want to look for where it says 0.05. So if you look, oops, sorry about that. Here's 0.05. Because if you remember, it was the 0.05. Everybody go on 0.05 for Z. All right. So then what you want to do, here, let me kind of zoom out. You just want to go all the way down to the bottom. And you see where you have the Z value, and then you have that vertical line that I just drew. You want to see where do they intersect. So if you look at where do they intersect, it intercepts here. So we'll say Z of 0.05 is equal to 1.645. And that's how you find the answer. Any question on how I found 1.645?
Do you mind doing it one more time?
Yeah, sure. So let me erase everything. All right, so right here where it says one tail, you want to look where it says 0.05. So here you go, 0.05. So since that's where I found 0.05, that means I'm going to select that entire column. So that means we're going to go all the way down. I'm going to try to see if I can fit there. So where it says 0.05, that means we're going to go all the way down. So you select the entire line where it says 0.05. And then what you want to do, here goes the Z value right over here. So that means you want to select that row. So if you look at where do they intercept at 1.645. So that's how you get the 1.645. Any question in regard to how you get the 1.645? There's actually another easier way to do this. It's pretty much all you have to know what the confidence level. What was our confidence level for that last problem? Or what was the confidence level that we were doing it for right now?
0.90.
Yeah, 0.90. If you look right here, you see how it says confidence level? And then if you look right here, it says 90%. So you go 90% and you get the number on top and you get 1.645. All right, but that's how you get 1.645. Any question on how I got 1.645? All right, so let me move this over. So you get 1.645. All right, and that's it for B. All right, any question in regard to B? All right, so let's do C. So C, we technically already did it. If you look at C, it says find the point of estimate. So the point of estimate is just p hat. So we found p hat to be equal to 0.6298. So if you look up here, that's what we found it to be. We found p hat to be 0.6298. So let's go down to D. So for D, it says find the margin of error. So to find the margin of error, we're going to use this next formula where we say margin of error is equal to Z alpha divided by 2 multiply p hat times 1 minus p hat all divided by n. So right now what I'm going to go ahead and do, I'm going to go ahead and substitute everything in. So Z, I already found this to be 1.645, so we'll put 1.645. We'll put radical. If you look at it, you get p hat, which is 0.6298. Now we're gonna do 1 minus p hat, so you do 1 minus 0.6298. We divide this by n, which n was, what was n? 1,783. 1,783. And that's your inputs. Any question on how I substituted the Z value, the p hat, or the n value? Okay, so what I'm gonna go ahead and do, I'm gonna go ahead and transition over to ClassCalc, where I could do this in ClassCalc. So we'll go over here. All right, so in ClassCalc, first you're gonna put 1.645. Then you're gonna say, hey, let's multiply it. And you're gonna get the radical. So if you look right here, it says radical A. So in your calculator, you look for radical A. And now I'm gonna put everything under radical A. So you put 0.6298. Then you want to put multiply, and then you put parenthesis 1 minus 0.6298, close parenthesis. Now you put divide. So you want to hit the divide button, and you put 1,783. Oh. All right. And that's how you enter it into ClassCalc, and that's our answer for margin of error. So we'll say margin of error is 0.0188. And that's it for D. Any question for D? All right, so let me transition over to the notes for that way you can see how I put the answer. So if you look right here, that's my answer. All right, so lastly, we're gonna go to part E. If you look at E, it says construct the 90% confidence interval. So in this one, this is where we're gonna say P hat plus or minus my margin of error. So technically we're gonna say P hat, which P hat is 0.6298. And we're gonna add it, but you're also gonna subtract it from margin of error, which is 0.0188. So just remember for this one, you have to write it two ways. So you're gonna say 0.6298 minus 0.0188. We're also gonna say 0.6298 plus 0.0188. So up next, I'm gonna go ahead and go to class calc and you do that calculation. That would be it for F. Oh, sorry, E. So we'll say 0.6298 minus 0.0188. So you get 0.611. I'm going to go back here, delete the negative, and you put addition. And you go 0.6486. Any question in regard to that last problem? So that's how you find confidence interval for population proportion. Up next, we're going to get into the interpretation of this. So for part F, it says, is it plausible that the true proportion for all registered voter who are in favor of the death penalty for those convicted of murder is 75%? So for this one, saying, is it plausible that the confidence interval is correct? Well, is the confidence interval always going to be correct? Like yes, no, maybe? Because right now the confidence interval telling us it should be between 61% and 64%. But the thing is, the confidence interval is not always going to be correct. So this one say, is it plausible? And we're going to say yes, it is plausible for P to equal to 0.75. And that's all you got to do for F. So for part G, it's saying based on your confidence interval, is it likely that the true proportion for all registered voters who are in favor of the death penalty for those convicted of murder is 75%? So this one's saying based off of our confidence interval. So we want to go based off of our confidence interval. So for this one, all you have to do is see 0.611 and 0.6486. You have to kind of know 0.75. It doesn't fall in between. It actually falls above it. So since 0.75 doesn't fall between 0.611 and 0.6486, based off of our confidence interval, we're gonna say it's not likely that 75% is P. So we're gonna say and that's it. Any question for part G? Yeah, I could explain it again. All right. So if you look at part G isn't like it's telling you based off of your confidence interval. So we want to just use our confidence interval. Part F, if you look at it, it's not asking you to use a confidence interval. It's telling you, can 75% be the population proportion? So anything is possible. So that way you say, yeah, P can equal to 0.75. But for part G, since part G is asking us in specific, can 75% be the true population proportion, given that the confidence interval is 0.611 and 0.64? Since 75% is not in between these two values, that's why we're saying no. Because say if they would have said 62%, since 62% fall between 0.611 and 0.64, 0.62 or 62% will say it is likely 62% could be the population proportion. But in this case, oh, sorry. Since they're asking us for 75% and 75% is well above the interval, that's why we say 75% is not really likely to occur. All right. Any other question in regard to G? All right. All right, so give me a minute. The screen's froze. All right, so let's do this next problem. So for this one, says a assembly line does a quality check by sampling 50 of its product. It finds that 16% of the part are defective. So first thing we're gonna look here is just to see what's given to us. So the first thing that they give us is the sample. What do they tell me the sample is equal to? Yeah, 50, perfect. So if you look right here, it says 16% of the parts are defective. So talking about of these 50, 16% of them are defective. So since the 16% is coming from the sample of 50, we're gonna say P hat is equal to 16%. All right. Everybody good for that? That N is equal to 50, P hat is equal to 16. Cool. All right, so for this one, we're gonna go ahead and find the X value. So if you kind of notice for this one, they don't tell us the X value. So the formula P hat is equal to X divided by N. So in this case, what is P hat equal to?
0.16.
Yeah, 0.16. And if you look at N is equal to 50. So if I wanted to solve for X, how can I solve for X? Well, for this one, you could just multiply by 50. Perfect. So you multiply the right side by 50, but you also multiply the left side by 50. So if you multiply this out, 50 times 0.16 is 8. This will get canceled out, so you get X is equal to 8. Everybody good how I got X is equal to 8? All right, so for this one, we're actually going to do this in class calc. So have class calc available for you. So in class calc, what I want you to do So in ClassCalc, what I want you to do is hit the stats button, go over where it says test. Let me move this. And if you look right here, if you look at the second row where it says one prop z int, that's what we want to use because we want to do the one prop z interval. So I'm going to select that. All right, so if you look right here, it wants the x value. That way we kind of spend some time getting the x value. The x value in this case was 8. So you put 8. Up next, you want to give it the n value. The n value was equal to 50, so we'll put 50. Lastly, you want to put the confidence level. So the confidence level, you put it in decimal. We want it a 95% confidence level. Wait. And if you look at it, it'll give us the answer. Any questions so far how we got the answer at 0.058384 and 0.261616? All right, so let me put that for my answer here. So I'll say 0.0584. All right, so let me take you to the notes for that way you can kind of see how I answered it there. Yeah, I can show you how to do the TI-83. All right, so that's how you enter the answer for the confidence interval. So if you look at the top portion, that's your confidence interval. All right. Any question how I found the confidence interval using ClassCalc? Oops, took away. All right, so right now what I'm going to go ahead and do, if you look at the problem, it says find the confidence interval and interpret this interval. So right now, I'm not going to interpret it right now. I'm going to show how to get the confidence interval if you have a TI-83. So let's do the TI-83. So let me share the screen with you. Lab 2, Lab 2, Lab 2, Lab 2. All right. So if you're doing this as a TI-84, what you want to do, you want to hit the stats button. You want to move it over where it says test. And then if you look all the way down, well, you actually have to go way down. If you look right here where it says A, it says one prop Z interval. So I'm going to select this one. So you select it. If you look at it, it's going to ask for your X value. So for X, X should always be a whole number. If you give it a decimal, it's not going to like it. So if you put 0.16 here, it's not going to like that you gave it 0.16 because it could go like, why are you giving me a decimal when I'm expecting a whole number? So you put the whole number, so you put 8. You put N in this case was 50. You put confidence level in this case scenario was 0.95. And we go to calculate. And if you look at it, they gave me exactly the same answer that we did using ClassCalc. All right. Any question in regard to the TI-83 or 84? All right, perfect. All right, so up next we're gonna do the interpretation. So the interpretation of this should have 3 parts to it. So we'll go with part by part. So here are the 3 parts that you're gonna have to include in your interpretation. You have to say how confident you are. You have to tell me what P is. When I say what P is, I mean what does P represent? Like, what is the population parameter that we're looking for? And then what you have to do, you have to tell me what the confidence interval is. So those are the three things your interpretation should have. So let's get started. So the first thing what you want to do, you want to put how confident you are. And that goes back to my confidence level. So if you look at this problem, what did we say the confidence level was? Or you can put it in the chat or just yell it out. Yeah, 95. So we say we are 95% confident. So that's always going to be the first thing you want to put. You want to say how confident you are. So in our case, we're 95% confident. All right. Next thing what you want to do, you want to put what does P represent. So what is the proportion that we're solving for? So for this one, what is the proportion that we care about? Because what does the 16% represent? Then does it represent the 8? Well, what does 8 represent? Like, what does 8 tell us? When we say 8, what is 8? Well, because if you look at it, it says 16% of what are what? Cool. So it's talking about the defective parts. So we're gonna say we are 95% confident. So we're gonna say we are 95% confident that the population proportion of defective items, because that's what P represents. It represents the defective parts. So we just want to say that the population proportion of defective, well, here, let me put parts instead of item. Because that's what the P represents. It represents the proportion of defective parts. And then you say is between, and then you put your confidence interval. And that's 0.0584 and 26 0.2616. And that's your interpretation. So we're going to say we are 95% confident that the population proportion of the affected part is between 0.0584 and 0.2614. And we're all done with A. Any question in regard to A? Ooh. All right, let's do B. All right, so for this one, we're not going to do any mathematical operation. All we want to do, we're going to say, how should this item get affected? So we just want to say, is it going to go up? Is it going to go down? Like, what's going to happen? So this one, there should be no math involved. So for this one, it said, if we decrease the confidence level to 90%, what will happen? So if you remember, our confidence level was 95%. And we're saying, what would happen if I decrease it to 90%? So saying, what will happen to the critical value? What's going to happen to the margin of error? What's going to happen to the confidence interval? So what's going to happen to the critical value? All right. Well, Brianna already said it. She said it's gonna go down. Cool. Yeah, that's correct. What about for the margin of error? What do you think will happen for the margin of error? What's gonna happen to the margin of error? Is it gonna go up or is it going to go down? Sweet. So we got down again. Perfect. 2, 4, 2. Lastly, what's gonna happen with the confidence interval if we're making the margin? Well, if we're doing a 95%, we go to 90%. Well, for this last one, it should be going down. All right, so confidence interval should also be going down. And we're done. So you just gotta know if we decrease the confidence level, the critical value, the margin of error, and confidence interval all should go down. All right, but that's it for that last problem. Any question for this problem? Oh, and we're you skip C. All right, so let's go down to the next problem. Oh, not next problem. All right, so for this next problem, what we're gonna do, we're gonna determine how big of a sample size do I need to have a pretty accurate data set. So depending on how accurate I want this data set to be, I'm either gonna need a big sample size or I'm gonna need a small sample size. So if you look right here, it has n because n corresponds to sample size. So if it's telling me, so for the type of problem, what's gonna happen, they're gonna tell you, hey, we have a margin of error and we want it to be 90% or 80% confident. How big of a sample size should we get? So kind of depending on how big or how small we want the margin of error. If we want a small margin of error, we're gonna need a big sample size because if we want it to be accurate, you're gonna need a big sample size. But if you want a big margin of error, which saying that it's not gonna be as accurate as it could be, then the sample size is gonna actually be smaller because you kind of have to realize the give and take. If you want a small margin of error, you're gonna have to kind of get a big sample size. But if you want a low margin, well, a big margin of error, then you're gonna have to get a small sample size. So for this one, there are gonna be two different formula. And the two different formula are yes in case if I know p hat or if I don't know p hat. So in this one, we know what p hat is equal to. So I know what p hat is. So if I know what p hat is equal to, we use this formula on top. If you don't know what p hat is equal to, that's when you use this second formula. So if I know what p hat is equal to, you use the first formula. If I don't know what p hat is equal to, you use the second formula. Any questions so far for the when to use the first formula versus the second formula? Sure. Nope, nope, nope. Perfect. All right. So I'm going to show you how do they get the second formula when we don't know p hat. So when we don't know p hat, so when we don't know it, what we do, we assume p hat is equal to 0.50. And what we do, we substitute into this first formula. So we get n is equal to 0.50 times 1 minus 0.50 times z alpha divided by 2 divided by margin of error square. So what we're gonna go ahead and do right now, we're gonna go ahead and multiply these two out. So we're gonna say 0.50 times 1 minus 0.50. Yeah. So I'm gonna go ahead and transfer over to Class Calc right now. So we'll say 0.50, and we're gonna multiply this by 1 minus 0.50. Press enter. If you look at that, you get 0.25. So let's go back to my notes. Not bedroom. So if you look at it, you get 0.25, and this is how this 0.25 come to be. So for the 0.50, the 0.50, we're just assuming p hat equal to 0.50. So it had nothing to do with a last problem or anything like that. It is saying if I don't know what p hat is, I'm just gonna assume it's 0.50, because if we only have two options, we're just assume both options are equally likely. So since both options are equally likely, that way you say it's 0.50. But when you do 0.50 times 1 minus 0.50, well, you get 0.25. All right. Everybody good with the formula? All right, so let's go ahead and use the formula. So for this example, it says a sociologist wanted to determine the percentage of residents of America that only speak English at home. What size sample should be obtained if she wishes her estimate to be within 3 percentage points with a 90% confidence, assuming she uses the 2000 estimate obtained from the Census 2000 supplementary survey of 82.4%. So for this one, do you want to estimate? Well, P is the proportion of American that speak English at home. Oops. So that's what P is. That's what we're trying to find. We're trying to find the proportion of Americans that speak English at home. So if you look at the first thing they tell us in the second sentence, it says what size sample. So when it says what size sample or what sample size, that means what we're trying to do, we're trying to find what n is equal to. So we don't know what n is, so we're trying to find what n is in this case scenario. Because it says what size samples should be obtained. So that's your hint that's telling you you're solving for n. All right. So for this one, what do they tell us the confidence level is? Confidence level. Perfect, 90%. Cool. If you look at this one, it has to be within 3%. So margin of error, if you kind of remember margin of error, you do plus or minus margin of error. When you're doing plus or minus, that's telling us it had to be within a certain percentage. So technically here, our margin of error has to be 3% or 0.03. And the keyword here is the within. Anytime you say within, that's your clue that's telling you that's the margin of error. Okay, anytime we want margin of error, the margin of error should be within a certain percentage point. All right, so we found margin of error. Any question in regard to margin of error? Okay, so for this one, do they have like absolutely no clue what the proportion of American that speak English at home? Or do they kind of have a rough idea of what it could be? Yeah, good. Well, not the 84%, but the 82.4. Yeah, there you go. So that's our p hat. So if you look at this one, it's not like we're going to a blind, like we actually know what it used to be. So we're kind of thinking, okay, it should still be somewhere near that. It's probably not going to be 0.824. It might be something different, but at least we know like what that value is. So we're not going into it blind. We know that the last time they did this census survey, they were able to get that was 82.4%. So at least we know that information. So which formula should I use? Should I use formula A or should I use formula B? So A or B? Yeah,
A.
good. Yeah, perfect. We're gonna use formula A because we know what the well, we know P hat. So since I know what P hat is, I know P hat is equal to 0.824. We're gonna use formula A. So we're gonna use N is equal to P hat times 1 minus P hat. And then we're going to say V alpha divided by 2 divided by margin square. All right. Everybody go while we're using this formula? Okay, good. I'm going like, why? Why me? No. All right, good. All right. Great. All right. So up next, the only thing we have to find is we're going to find this Z value. So the way we're going to find the Z value, we're going to look at our Z table. So if you look at it, the confidence level is 90%. So I'm just gonna look for confidence level of 90%, and I'm gonna see which Z value is associated to that confidence level. So we'll say, all right. So if you look at it, here's 90% confidence level, and if you look right above it is 1.645. So Z alpha divided by 2 is 1.645. Everybody get how I found 1.645? All right, so I'm gonna go back to my notes. So we'll go chapter 7. So I'm gonna erase this. And I'm gonna put, here, let's do a different color. We'll do 1.645. All right. So now what I'm gonna go ahead and do, I'm gonna start substituting stuff in. So for p hat is 0.824. Same thing for this p hat over here is 0.824. Same thing for this E right here. Oops. The E is your margin of error. Margin of error, we said was 0.03, so you put 0.03. And that's it. So that's how you substitute everything into that formula. Any questions so far for the substitution? Okay, so I'm gonna go over, transition over to Class Calc, and I'm gonna enter all of this into the calculator. You can also do it with the TI-83. It shouldn't be anything that much radically different. So you go 0.824. You multiply this by 1 minus 0.824. Then you get 1.645. You divide that by 0.03. you close the parenthesis, and make sure you do it to the second power, so you do x squared, and we got our answer. So we get the answer of 436.04. Any question on how to enter into ClassCalc? Okay. Yeah, cool. Good job, Nancy. All right, so let me transition back to my notes. Okay. Everybody good on how I got 436.04? Yes. All right, perfect. So up next, what I'm going to go ahead and do is we're going to go ahead and find the final answer, because the 436.04 is not the final answer. So if you remember about sample size is always a whole number. So it's not like you could have half of a sample. It's either you have that sample or you don't have the sample. So this is where you have to be careful at, because the 436.04 is not going to be your final answer. What you have to do, you take this 0.04, and what you want to do, you want to upgrade it to a, so you upgrade it to a sample. So pretty much what you're gonna have, instead of saying 436.04, since we're gonna get that 0.04 and upgrade it to a sample, you're actually n is gonna equal to 436. Oh, sorry, 37. You always upgrade it to the next highest one. And the reason why we upgrade it to the next highest one, if you were to leave it at 436, that's gonna make my margin of error go up. And I don't want my margin of error to go up. I want it to be at 3% or below 3%, but I don't want it to go above 3%. So that's the final answer for that last part. Any question on the 437? All right, so let's practice on some more example. Wait. Well, actually, let's do this one first, and then I'll let you do that one. So let's do this one for extra practice. It says a survey estimate that 20% of all Americans aged 16 to 20 drove under the influence of drug or alcohol. A similar survey is planned for New Zealand. They want a 95% confidence interval to have a margin of error of 0.05. All right. So what is the 95%? What should I label 95% as? Cool, CL, perfect. CL is 0.95%. All right, what should I label 0.04 as? Yeah, E, perfect. We're on a row. Now let's see, what should I label 20% as? I don't think you guys should, well, the 20%, that's your P hat. All right, so we know confidence level, we know margin of error, and we know our P hat is equal to. So for part A, it says find the necessary sample size if they expect to find a result similar to those in the United States. So if you look right here, it says find the necessary sample size. So we have to see what the sample size is. So we have to say N. And which formula should I use? Should I use the formula where I know P hat, or should I use the formula that we don't know what the P hat is equal to? So should I use the first formula or should I use the second formula? Cool. So yeah, so you want to use the one that we know. So we use p hat times 1 minus p hat times v alpha divided by 2 divided by margin of error square. All right. So let's go ahead and start substituting in. So we,
Professor,
yeah, what's up?
is the confidence interval and the confidence level the same thing?
It's not the same thing. Well, like the confidence level and the confidence interval should be the same for each other. So if my confidence level is 95%, the confidence interval should be for a 95% confidence level. Does that make sense?
Yes.
All right, good. All right, so we're gonna do p hat. So p hat is equal to 0.20 times 1 minus 0.20. I don't have a z value right now, but I know margin of error is 0.04 square. How can I find the z value? Where do I have to go?
The T table.
Perfect, the t table. And in the t table, we're gonna look for 95% confidence level. So let's go to the t table. So let me erase this. Jump. Oh, actually, let me just erase that. All right. So if you look at it, we're looking for 95% now. So here go 95%. If you look right above it, 1.96. So 1.96. Everybody got on 1.96?
Yes.
Right. So let's go ahead and let's go back. Good. So you got 1.96. All right, so what I'm gonna go ahead and do, I'm gonna finish off A, and I'm gonna do this in class Cal. So, well here, I'll do this in the TIA3 in case you want me to do it in the TIA3. All right, so let me turn you on. So we'll say 0.20, parenthesis, 1 minus 0.20, close parenthesis, open parenthesis, 1.96 divided by 0.04. You close it, you put it to the second power, and ta-da! Perfect, Elizabeth. So you get 384.16. So if you look at it, 384.16 is not my final answer. We have to round this up to the next whole number. So the final answer should be 385. All right. Everybody good for part A? All right, so let's move over to part B. All right, so if you look at part B, it says suppose they don't know the proportion. So we don't know p hat is equal to 0.20. So we don't know this information. So now what is the required sample size? So if I don't know what the sample proportion is, now we have to figure out the different formulas. So which formula am I going to use now? So we use the second formula, perfect. So we say n is equal to 0.25 times z alpha divided by 2 divided by margin of error square. Any question why we're using the second formula? Cool. All right, so the good thing about this one, my confidence level gonna stay the same, my margin of error gonna stay the same, so I'm gonna substitute everything in. So for z alpha divided by 2, that's 1.96. Margin of error, that was 0.04. So let me go ahead and do this in my calculator. So I'll say 0.25, 1.96 divided by 0.04, you square. And one thing, just be careful. Most students always forget to square, especially on tests. So don't forget to square. So for the answer, you should get 600.25. So what should be the final answer? Yeah, 601. Cool. Thanks, Elizabeth. Thanks, Brianna. All right. Any question in regard to this last problem? All right. So before we move on, I kind of want you to notice the big difference that happened if I do know the sample proportion or if I don't know the sample proportion. If I do know the sample proportion, we only had to do a sample size of 384. But if you look at it, if I don't know the sample proportion, now we're doing a sample size of 601. It's almost, well, it's not double, but it's almost like 32% more than what we originally had gotten. So that was important. If I do know what the sample proportion was for a prior study, you do want to use it because it could make it a smaller sample size that you need a smaller sample size. But if you have no idea what it could be, then you're going to need a bigger sample size because if I don't know what the sample proportion is, you're going to need a bigger sample size. All right. Any question in regard to this last problem? All right. So what I want you to do, I want you to practice on what we learned today, and then this will be it for today. So what I want you to do, I want you to practice on A and B. So A and B is pretty much what we did today. A, you have to do a confidence interval. For B, you have to find how big of a sample size do we need. So try doing A and B. If you get stuck throughout the process, let me know for that way I could help you out. Or if you found the answer, let me know. That way I could tell you if you're right or if you're wrong. And you can use it by either using the TI-84 or by using ClassCal. Well, remember how to find p hat. P hat x divided by n. So yeah, it should be 16 divided by 100. Keep on thinking. Not a bad thing. It's a good thing. Okay, so let me give you the answer. So hopefully you should have gotten the answer is 0.0656 for the lower bound, and for the upper bound you should have gotten 0.2544. So yeah, so you're right, Alondra. Good job. Any question in regard to part A? All right, so I don't see anybody with an answer for part B, so I'll give you a couple more minutes to work on B. If you have, what are you confused about, Brianna? Well, if you actually go to your calculator, if you go to class calc, it only want n, x, and your confidence level. So technically you don't really have to divide it, because for n you put 100, for x you put 60, and then confidence level you put 0.99. So you don't really have to do the 16 divided by 100. You could just do that. Yeah, you're welcome, Brianna. Anybody got the answer for part B? Let me check that for you, Nancy. Yeah, good. So yeah, for part B, you should have gotten n is equal to 0.16 times 1 minus 0.16. And then you get 2.576, all divided by margin of error, which is 0.04. And you square, and you should get 558. And that's all you had to do for part B. And remember the 2.576, I got that by using the T table. Any question in regard to B? All right, I guess no question. All right, so that's pretty much it for today. So just to remind you, on Monday you're gonna have a quiz. So the quiz is gonna cover pretty much what we covered today. So if you didn't understand today's lecture, you want to understand today's lecture by Monday because Monday quiz will cover this. If you understand today's lecture, keep on practicing, just for that way you won't forget anything that you learned today. And that way on Monday when you have the quiz, it should be pretty simple. And just remember the quiz is gonna have 5 questions. You're gonna have 30 minutes to do the quiz. So it's gonna be a time quiz. So once you start it, just know pretty much it keep track of your answer, and after 30 minutes, it's gonna close up. All right, any question before I close down this meeting? Office, what do you mean by office hour? Well, the office hour I had them before the class. So for the correction are due on Wednesday. Since yesterday I spent time doing all of the corrections, so everybody should have their tests and it should be with the correct point. So the correction should be due next Wednesday. So here, let me check because there should be a place for you to submit it. If not, you create it right now. Let's see. Nope, you're not that class. It's this class. Let's see. Yeah, cool. Yeah, so if you look at it, I already did the test correction. So test correction for test 2 is right over here. So all you have to do is just click it. Cool. Right here, I guess there's something like submit assignment. So you want to submit assignment, and then you're gonna just upload the file. So so the way that you're gonna submit them, because I know some of you probably don't have a printer. So I know that some of you probably don't have a printer or anything like that. So you don't have to print out those test correction form that I gave you. But what I want you to do it on a sheet of paper and keep the same format. So I want you to draw the box that just said like how many points was it out of, how many points did you receive, so on and so forth. So that way it will be like that. But I do want you to keep the same format, but you don't have to print out those because some of you might not have access to a printer. So I don't really want to penalize you just for not having access to a printer. So you do on a sheet of paper, keep the format where you show the correction, you show the explanation, and so forth. Any question in regard to that? Yeah. Cool. Yeah, you're welcome. Yeah, and like I said, whatever we went over today, that's what quiz gonna be on Monday. Did you record the correction? If you're talking about on Tuesday, or did I record the correction on the test? The test should have the correction. If you got full points for something, then you know it was already corrected. Any other questions? All right, sweet. All right, so I'm gonna close down today's meeting, and that's it for today. I'll see everybody Monday. Have a good weekend.